On this F-150 with the 2.7 EcoBoost, P0172 usually points toward a rich running fuel control concern. In plain language, the engine computer may be seeing more fuel than expected for the amount of air it thinks is entering the engine. The truck may have a check engine light, rough running, poor fuel economy, fuel smell, or hesitation, but those symptoms can vary. Broad possible areas can include air measurement, fuel delivery, exhaust feedback, intake and vacuum integrity, fuel quality, wiring and connector condition, and the inputs the module is using to make fuel decisions. For this one, the usable diagnostic path is the general diagnostic method, so do not treat this as a completed P0172 pinpoint test. Use it to set up the diagnosis, prove the concern, and avoid guessing. Start by confirming the concern is actually present before you apply the diagnostic process. If the concern is not present at the time of testing, do not replace modules or other components just because a diagnostic path might appear to point that way. Then make the normal preliminary checks. Look for anything obvious tied to the customer complaint. Check for related OASIS or TSB information if available. And look closely at previous repairs that may have been done incorrectly. Before getting deep into fuel control, make sure the battery and charging system are operating correctly and verify battery SOC is greater than 70% before beginning diagnostics. Then scan all network modules for system or symptom codes that relate to the concern. If other codes are present, use them to decide where to start. Circuit-related codes get handled before system or performance-type codes, because a bad feed, ground, connector, or signal circuit can make the fuel control data misleading. If there are several circuit faults, look for a common power or ground problem instead of chasing each fault separately. Next, do the basic underhood checks in order. Inspect the wiring harnesses for damage, chafing, and routing. Check fuses, circuits, and connectors for continuity and correct installation, and make sure components are connected properly. Then look over the vacuum lines and intake system for leaks, routing problems, or restrictions. Inspect hoses for damage, leaks, blockage, and routing. Check fuel quality, including octane, contamination, and winter or summer blend. Inspect the fuel tank and fuel lines for damage, leaks, and routing. Also check coolant level and quality with the engine at the correct operating temperature. Check oil level and quality, including contamination and maintenance condition. And inspect the exhaust for damage, restrictions, and routing. For a rich code, these basics matter because a mechanical, fuel, air, or exhaust issue can drive the data before an electrical test ever starts. When you do move into electrical testing, protect the connectors. Use Rotunda Flex Probes NUD105R025F or Terminal Probe Kit 418S035 when connecting test equipment or jumper wires to pins. Check male to female terminal fit with the mating pin and look for normal separation force. Very low separation force points to a damaged pin. If the connector shell is adding drag on a small terminal, remove the pin from the shell as needed so the separation force check is accurate. If a connector, pin, or terminal is damaged, repair that hardware by replacing the damaged connector, pin, or terminal. Use the scan tool to read PID input values, output states, and diagnostic states. Watch the data in the data logger so you can see what the module is using without taking the vehicle apart unnecessarily. Where the function is available, use output state command PIDs to command outputs such as the cooling fan, engine RPM, or other controlled outputs. Do not apply power or ground directly to module switched components with jumper wires unless the specific test calls for it, because that direct connection can damage the component. Before blaming a module, understand how that system is supposed to operate. Make sure programmable parameters are set correctly, resolve DTC-directed checks first, test the hardwired and networked inputs, test the outputs, and check for module software updates. If the output works normally, turn your attention back to the inputs feeding the decision. Do not rely on an unloaded voltage reading to find every wiring problem. On a power-providing circuit carrying approximately 200 to 1000 milliamps, load the circuit with a 250 to 350 milliamps test light and measure voltage with the DMM while the test light is connected. As a guide, conductor sizes 24 gauge, 0.5 millimeters or smaller, are generally used to carry approximately 1000 milliamps, 1 ampere or less. For circuits carrying more than 1 ampere, load the circuit with a device that requires similar current. Conductor sizes 20 gauge, 0.8 millimeters or larger, are generally used to carry 1 ampere, 1000 milliamps or more. A voltage drop under load points toward excessive resistance, and voltage drop testing is the better method on higher current circuits. Check ground circuits by measuring voltage drop while the component is operating or trying to operate. Use an ohm meter on ground circuits only if the battery has been disconnected. For small diameter wires, 18 gauge and smaller, expect less than 2 ohms. For most wiring harness circuits, expect less than 2 ohms of resistance. Remember that a standard DMM ohm meter's low resistance resolution is approximately 0.1 ohm, so its accurate use is limited to circuits carrying less than approximately 5 amperes. Use voltage drop instead of only a low resistance measurement when current is higher. Reverse the DMM leads and make sure the resistance reading does not change unless the circuit contains a semiconductor. To check for an unintended path to ground, disconnect both ends of the suspect circuit and measure between that circuit and ground. The expected resistance is greater than 10,000 ohms. To check for continuity to another unpowered circuit, disconnect both ends of both circuits and measure between them. Again, the expected resistance is greater than 10,000 ohms. To check for contact with a powered circuit, disconnect both ends of the suspect circuit, turn ignition or run power on, and measure voltage to ground. The expected result is no voltage present. Use backprobing only when the test has to be done with the circuit operating normally, when voltage drop testing requires it, or when opening the circuit could change module behavior. Use proper backprobes, and do not force test leads into connectors. Backprobing is not the right move for a simple single-point voltage check, and it is not the right move for an ohm meter continuity or open circuit check between 2 points. Isolate the circuit and test normally. When jumper wires are used, use fuse jumpers. The recommended universal testing jumper wire fuse is 5 amperes or less, unless the load requires a larger fuse. Use flex probes or equivalent to prevent terminal damage, but do not use flex probes to carry high current greater than 5 amperes. Follow the test directions carefully, and do not patch a failed circuit with a parallel wire until you understand why the circuit failed and have dealt with the root cause and any nearby wiring damage. For a voltage drop check, connect the voltmeter at the beginning and end of the suspect circuit and test the circuit while it is operating or trying to operate. Follow conventional current flow for meter lead polarity. A 0-volt reading means the meter connections are bad or the component is not turned on. In 12-volt circuits, normal circuit loss is usually less than 0.5 volts, with an expected loss of less than 5% of circuit operating voltage. A reading greater than 0.5 volts indicates abnormal voltage loss from high resistance in wires or connectors. For a voltage in, voltage out test, put the negative meter lead on ground or battery negatives. Then use the positive lead to measure the power side of the load and the ground side of the load. The power side should be within 0.5 volts of battery voltage. The ground side should be greater than 0 volts, but less than 0.5 volts. During that test, 0 volts or source voltage points to an open circuit. The takeaway on P0172 is to keep the diagnosis disciplined. Prove the rich running concern is present. Handle circuit faults before performance faults. Make the basic mechanical and fuel quality checks. Protect the terminals and use loaded circuit testing when the data points you toward wiring. If the path stops making sense, pause, recheck the earlier diagnostic path, and avoid guessing. For more diagnostic training, visit stepdiagnostics.com.